Hello, my name is Evan Cleveland, and this is Lab 1 for Physics 2. I'm going to go try and go kind of quickly, and I may skip over some of the more calculation type things, and obviously we've all done the lab, so I'm not going to explain every single detail. Try and talk about more about the big ideas here. So, for this lab, the goal is to approximate the number of excess electrons, or the lack of them, and predict the interactions between a piece of tape and other objects. We're going to approximate the electrons by trying to use one tape to cause another to seemingly float against the force of gravity. Big physics principles are listed there. The biggest ones are going to be the fact that like charges repel each other, and also Coulomb's law will be very important. And you can see the results at the bottom of that slide. The biggest assumptions we're going to be making are the fact that we're going to assume that the tapes have a centralized point charge rather than even or uneven distributed charge across the entire piece of tape, which will allow us to use a free body diagram to model the scenario. And then the other big one is that we're going to assume the pieces of tape have the same charge, which allows us to simplify Coulomb's law a lot, and we kind of average the charges between the two pieces of tape. And of course, we're going to assume air resistance is negligible because of the standard physics reasons that you would. Here's the free body diagram. The biggest takeaway is here at the bottom in the fact that electric force is going to be equal to the negative gravitational force, the same magnitude but opposite signs. Here are the figures for part 1 of the lab. Some things here, we're going to define the system as the charged pieces of tape and the objects that they are supposed to be interacting with, and the surroundings will be everything else. The initial conditions are essentially the pictures that you saw prior. I did measure the tapes to have a length of 0.2 meters. And then for the actual lab procedure details, essentially, we all did it, but we're going to rip them off the table, test to make sure that they have a charge with a hand, and then check the reactions between the tapes. You can see my predictions here. I predicted that the two U tapes would repel each other. A U tape would be attracted to a neutral object because of electrostatic induction and the rearrangement of charges inside of a neutral object. And basically, if the U tape is positively charged, it should attract a negatively charged plastic pen, which you can see at the bottom. That is what happened. The tape has a positive charge, and all of my other predictions did end up being correct. For part 2 of the experiment, we're going to have the same setup, same surroundings, initial conditions, and whatnot. But now we are going to create a bridge with one tape and then use the other tape to cause that to float above the table. And then we're going to measure the distance between the two pieces. Some lab question answers. We can assume because the tape has no change in momentum, the net force in the y direction is 0. In that the only objects that create a force on the floating portion of the tape are gravity and the lower tape. The free body diagram is shown in the model slide, and then you can see there my calculation for the mass of the tape, which will be used to calculate the gravitational force, and in turn the electric force. Here's some more calculations. I'm not going to run through them all, but basically calculate the gravitational force, and then you can see there the distance at which I measured between the tapes. And then we'll start with Coulomb's law, and then derive an equation where Q is alone on the left side. We'll plug in our numbers and get our result. And then we can continue from that by calculating the number of electrons that were gained or lost, in this case lost. More lab questions. Essentially, we can calculate the number of atoms by dividing the area of the tape by the area of an atom. And then the ratio based on the number of atoms and number of electrons that we've already calculated. This calculation is only possible assuming that the atoms are stacked neatly, almost in a lattice pattern. Otherwise, we would have no idea how many atoms there are. Here's my Glowscript code. It essentially does everything that I just talked about, but with a computer. This will be linked in the comment section of the YouTube video. And then this is the representation. Here we see, just like the free body diagram, the two force arrows are equivalent in opposite directions. And finally, for some discussion, the big discrepancies are the same things as the assumptions that we made. We use a point charge to represent it, but it really isn't. It's a bunch of smaller forces, and the pieces of tape are not equally charged. The source of error, if the charges were different, that would impact calculations. And then additionally, when we handle the pieces of tape, it's likely that they lose some charge as time goes on. if electrons had positive charge, protons had negative charge, the same interactions would take place, but we might change a positive or negative sign. The results would essentially be the same though. It is important to handle the charge types as little as possible, because when we handle them, they regain some of the electrons that they lose, which interferes with their charge. Big ideas in the conclusion here are that electric forces are kind of abstract in our brains, but we can actually really measure them, and they really have an impact on just about anything.